Okay, substitution. We are going to use, so do you remember when you were solving systems of equations and you would take something and plug it into another? So, like if I had 2x plus y equals 5 and y equals 2x, I could substitute that in there. Okay, we're going to use a similar technique to solve integrals, specific integrals. Okay. So this would be your kind of your baseline knowledge of substitution right now. Right? Now to set this up, can you calculate the derivative of that function? Okay, so remember it's change right? Outside cosine. The derivative. So derivative sine is cosine. Okay. This is mixed up. And then copy the inside times 2x, right? Okay. So what do you see here? I have the derivative of x squared, correct? This would be, this is the key to substitution, integration by substitution. If I ask you to calculate this, obviously the result should end up here, right? And the question is, how do I get to that? We're going to use what's called u substitution. And basically, we're going to use derivatives to help us solve integrals. Okay. So we are using a derivative. We're using the derivative of x squared to help us solve this integral. Okay. That's kind of the framework in your mind. It's still the same process using the antiderivative here. What's the derivative of x squared? 2x. Okay, let me show you how to use that to get back to this point. Okay. So this is called u substitution because we set something equal to u and we substitute. If I set this as x squared, so now I have this, correct? I put u in for x squared. Okay.
What? Okay, wait, go back.
So I've made x squared a single variable, so I can calculate the integral of this, correct? You know what the integral of cosine is? Yeah, sine, right? So the end result's going to have a sine u in it. That's why. So we can't do cosine x squared, but we can do cosine u. Single variable. Okay, that's what we're going to do. We're going to get rid of the 2x now. Okay, so what's the derivative of x squared? 2x, right? You understand that, right?
Yeah.
Okay. So we're just following step by step. Now I'm gonna move the dx to the right side here. So those cancel, right? All right. So I get du is 2x dx. those match?
Yeah.
They do, correct?
Except the cosine.
But I've already taken care of that part of the problem
Oh,
with du, right? It's cosine u.
oh, is it?
So if I underline here, okay, this, and this go together. Right,
Yeah.
so now, what do I put in for 2x dx? That's a lot easier to calculate. Okay, what's the integral of cosine? Right, and now we can plug u back in. So this is sine. That was disgusting.
I'm sorry. I didn't think it was gonna come out.
Even for a man, it was disgusting. So now what do we end up with? The original, right?
So what was the answer?
This is your answer.
Wait, I'm so. Why? That part of it was just. Well, you did all of that to get back to your other answer.
Well, okay, so if you're calculating an integral, you will have the original, right?
Oh,
This is
that
how you
was
get back
okay,
up.
us to know where.
This is where we start, and I showed you that this is the chain rule.
Oh.
So we're basically undoing the chain rule. Okay?
Okay.
Let me show you one more. I'm going to show you several more.
Yes, please.
I'm going to show you several more. Let's look at another trig function. So you need to get rid of this because we don't know the integral, right? So make that the u. Sine x cubed, can you calculate the integral of that?
No, wait.
You can, yes, but you can't just split things apart like that. This is trapped in a jail cell, you can't just take it out, right? So this needs to be something that I can deal with. That I can deal with a single variable, correct? U. So what I've just done is this.
Okay. Oh.
Right, we just kind of jump around. So, it's because of the chain rule. That's why it doesn't change. Outside copy, inside copy, part stays copy, right? So I have effectively done this, correct?
Yeah.
Right. Now, notice, what's the derivative here? 3x squared? It's
And
u.
so then.
So we're gonna get rid of this. So du. Is it okay if I just write it like this? That's,
Yes.
this is how you're gonna wanna end up.
Why?
You can, if you want, you can write du dx equals 3x squared, and then you can move it.
Oh, so then if it.
Eventually, you get to the point where you just skip that second step, okay?
So then it just,
So this here replaces these two items, correct? With du. So du. And then my integral can come along for the ride.
And then you just say,
See how much easier that is?
the U just turns into plus C.
Well, when you use it for the integral, the antiderivative.
For
So
that
what's
one.
the antiderivative of sine u? The u cosine. This is indefinite. It doesn't. This is like having sine dx here. You just, when you use it, when you calculate the antiderivative.
Oh, okay, so it's like.
Yeah, see, dx is now
That
du,
makes
so
sense.
if I gave you this,
So you can just plug whatever you wanted and make it disappear.
no, you can't just plug in whatever you want.
Feels like that's what we're doing right now. Yeah.
If I gave you this, what's the antiderivative?
Oh, no.
Right?
Yeah.
So the dx disappears,
Okay,
it's the
so
same
it's
thing.
not like an active.
You're good. You used it.
Okay.
What is our value of u?
What? X plus B.
Yeah, so that needs to be back replaced.
Okay.
So negative cosine,
I don't understand why.
I don't understand z either, but
How about we stop?
What's the line?
I get how to.
What?
Okay, wow. I think it was C when we do this. I was starting again.
you have integral limits.
And
You don't.
yeah.
We'll deal with that tomorrow, but do substitution. So you're basically saying, I can't do this, right? But I can set that equal to u, I can calculate this in here. That's the point, is to make it more simple.
The derivative of the outside is equal to the antiderivative.
It only works if the derivative of the inside is out here. That's the only time you can use this u substitution. Yes.
How is it gonna like access that network?
Calculate, evaluate, solve. Right now, you're pretty basic, you know.
Oh, sorry.
These are, it doesn't, I know these are difficult because you kind of, like, using a derivative to calculate an integral and, okay, so.
I definitely get
Let's
how
try
to
another
do
one.
it. Yeah, like I get how to do it, I just don't know why. Yeah.
Oh, why? Okay,
We have to.
so why do you don't have to understand why, but if you want to, here it is. The chain rule, right? Derivative outside, copy inside, derivative inside. We have to undo the chain rule. How do I undo the chain rule? With u substitution. That's why we have u substitution. It's the integral chain rule, okay?
All right. That
So
actually-
you're thinking, what's the derivative of the inside? It's right here. Now I can start messing with this and replace
Oh,
it.
that's why you have to have the derivative on your substitution.
Right. Yes.
And then you just said that's why I'm saying
Just
get
click.
it. Okay.
I wish every one of you had a light switch on the side of your heads.
That actually was what you did. No, it's.
They're not knowing. Okay,
Yeah,
it's
that's.
good to know. Let's try that one. Here's a non-trig function, polynomial. Right. Do you notice something? It's the derivative. 2x, the x is out here, but there's no 2, right? But we can still do this. Okay, it's gonna have a 1. So, this is gonna be u in here. And we still have to the 5th power. I can calculate that, right? So, this is where I stand right now. I've substituted u equals x squared plus 9, right? Okay, that's the derivative of that. Okay.
We have to go
Do those match yet? So we have x dx and x dx, but we don't have 2, right? So we have to divide 2 of it here.
or divide.
So it's 1/2 du equals x dx. Now it matches, right? You can do that. So now we have 1/2. You can put it in here or out here. It doesn't matter what you want to have.
One last. Where's the other place you could put it?
You can put it in here. It's a constant. You can move it outside. You want me to put it in here?
Well,
Doesn't
I
matter.
think so, but.
So just, you're thinking, okay, x and dx are gone, right? 1/2 and du are now in there.
Is that
You're
it?
substituting. Now you can calculate that integral, right?
So what do you do?
Now you do the math.
Oh, because.
This is the
you
easy
have to
part.
Put back the u to do the.
Everything has to be in terms of u.
Okay.
What's u to the 5th?
Thank you.
Good afternoon, Grand Valley High School. I'd like to get your attention, please. Staff, I apologize for interrupting the last 10 minutes of the class. But at this time, if you would not mind wrapping up your class quickly and then escorting your kids to our gym before lunch.
okay.
We have some things that we need to discuss real quick.
One,
So if you would not mind wrapping up your class again, I do apologize.
no lockdown. Good. All right, let's see. Hey, hold on.
Take care of a couple things and then.
Give me 2 minutes.
Thank you. Have a great day.
What's the integral of u to the 5th? And then you got the 1/2, right? Plus c. Now replace your u back in.
Oh my gosh, it's.
There you go.
Oh my gosh. Hey, don't give up. I'm not gonna do that. I don't know how to do it.
This would be considered to.
Then you need to come in and get some help.
Mr. Arthur, first of all,
I know.
I did all my homework yesterday and got several of the problems correct. Thank you very much. All of the ones that I didn't count for. Yeah, all the ones that didn't count for content. Yeah.
So that's the first day. Here's day 2 stuff. If you're in the spiral.
That sound. You think we're gonna get a? No. I feel like maybe something bad happened. Yeah, I was getting that. I bet it's about bullying. Or about that copy. Oh, maybe, yeah, I don't know. Now, it's gonna be
It's
something
on Google
that-
Classroom too, if you just want to.
I feel like it's gonna be about bullying. I feel like there's a lot of ways after everything.
No, it's not.
It's
Not due until Friday.
I feel like it really hurts my feelings when you truly